In the previous videos, we learned that it is possible to have square root of negative number, which involved a new number I, which is equal to the square root of negative 1. These numbers are called imaginary number and could be of the form bi, where b is real number and I is equal to the square root of negative 1. Numbers like 3i, 1.45i, minus 8i are all imaginary numbers. What if we have a number like 2 plus 3i? Will this be an imaginary number? Well, we can be sure that this part of the number is imaginary and this part is a real number. So this is a mix of real and imaginary part, and this is what we call an example of complex number. Real plus imaginary is an example of complex number. It's of the form a plus bi, where a and b are real numbers and I is a unit imaginary number. Observe that when a equals to 0, what is left will be an imaginary number, and when b is equals to 0 and we only have a, which is a real number. So what are the real and imaginary parts of a complex number? A is called the real part and bi is called the imaginary part of a complex number. Many of you might be wondering, does complex number has any real life applications? The answer is yes. It is widely used by engineers to study the stresses on beams, phenomena of resonance, the flow of fluids around the objects. It is also used in electromagnetism and much more. Well, that how exactly they are used here, that is an advanced topic. Now coming back to the basics, let me ask you something interesting. When the two complex numbers a plus bi and c plus di be equal, pause the video and give it a try. They will be equal only if both the conditions are satisfied. First, a is equal to c and second, b is equal to d. Yes, only if a is equal to c and b is equal to d will the two complex numbers be equal. Real parts equal and imaginary parts as well. To understand it better, let us consider an example. We are provided with the equation 4x plus I 3x minus y equals to 3 plus I minus 6, where x and y are real numbers. Then find the values of x and y. Now let us look at the solution. We are provided with the equation, and as we know, the two complex numbers to be equal, the 4x must be equal to 3 and 3x minus y must be equal to minus 6. So, equating the real and the imaginary parts of above equation, we get 4x equals to 3, 3x minus y equals to minus 6. And on solving, we get x equals to 3 by 4 and y equals to 33 by 4. Just as we do with real numbers, 2 plus 3 equals 5, 5 minus 3 equals 2, 2 times 3 equals 6, 4 over 2 equals 2. In the same way, we can perform the arithmetic operations on complex numbers. But how? That's what we will look in the next video.